Can't we use a jet engine to reach the boundary of the atmosphere, and then use a rocket engine to get out of the atmosphere? Theoretically, it is possible. Jet engines operate within the Earth's atmosphere by burning air and fuel to generate thrust, so they are limited to functioning within the atmosphere. Thus, jet engines alone cannot propel a vehicle beyond the Earth's atmosphere. However, it is feasible to reach the boundary of the atmosphere using jet engines and then use rocket engines to exit the atmosphere. In practice, NASA tested this approach in February 2018 with the X-57B drone. The X-57B utilized jet engines and electric motors to reach the boundary of the atmosphere, after which rocket engines were employed to exit the atmosphere. The test was successful, and NASA plans to apply this technology to future spacecraft launches. Nevertheless, there are drawbacks to this method. Jet engines are less efficient compared to rocket engines, requiring a significant amount of fuel to reach the atmospheric boundary. Additionally, jet engines face challenges operating at high altitudes, necessitating jet engines capable of functioning in the upper atmosphere. In conclusion, while it is theoretically possible to use jet engines to reach the atmospheric boundary and then switch to rocket engines to exit the atmosphere, there are some efficiency and technical limitations. Jet engines become less efficient at high speeds, and their efficiency approaches zero near the atmospheric boundary due to low air density. To overcome this, rocket engines are employed to accelerate before reaching the atmospheric boundary, and jet engines are used for additional acceleration after reaching it. It is worth noting that jet engines become less efficient as speed increases. Additionally, the density of the atmosphere decreases significantly as the boundary is approached, further impacting the efficiency of jet engines. Therefore, obtaining sufficient speed before reaching the atmospheric boundary is crucial, necessitating the use of rocket engines. This approach is commonly employed in the launch of small satellites and spacecraft, where their size limits the effectiveness of rocket engines alone in achieving the necessary speed to exit the atmosphere. However, it is essential to consider that relying on rocket engines for initial acceleration increases fuel consumption and launch costs. A detailed explanation of ICBMs. ICBM, or Intercontinental Ballistic Missile, is a type of ballistic missile with a range exceeding 5,500 kilometers. ICBMs are primarily developed to carry nuclear warheads but can also be equipped with chemical or biological weapons. An ICBM consists of two main components: the missile's body, bus, and the warhead. The missile is launched from the ground and propels itself beyond the Earth's atmosphere. The warhead, attached to the top of the missile, reaches the target to cause destruction. The missile body of an ICBM typically consists of three stages. The first stage, positioned at the bottom, provides the greatest thrust. The second stage propels the missile beyond the atmosphere using the thrust from the first stage, and the third stage, powered by the second stage, reaches the target. ICBM warheads can be categorized into nuclear, chemical, and biological warheads. Nuclear warheads harness the power of nuclear fission or fusion to unleash immense destructive force. Chemical warheads release toxic chemicals to harm the target, while biological warheads dispense pathogens to cause harm. Countries possessing ICBMs, classified as strategic weapons, include the United States, Russia, China, the United Kingdom, and France. Key characteristics of ICBMs include long range. With a range exceeding 5,500 kilometers, ICBMs can target locations on the opposite side of the Earth. High speed. ICBMs fly at speeds exceeding 20 kilometers per second after launch. Precision. Advancements in guidance systems enable precise targeting of objectives. ICBMs play a crucial role in a nation's nuclear security and act as a deterrent against nuclear warfare. However, their potential for causing large-scale civilian casualties makes them highly controversial, and their use could lead to severe international conflicts.